Welcome back, ladies and gentlemen, to the free response question review. Today we will be looking at the 2017 Calculus BC question number 5. It reads, let f be the function defined by f of x is equal to this particular function. It says, part A, find the slope of the line tangent to the graph at x equals 3. Alright, well if we're just going to find the slope, that's going to require some derivative. Now, before we get trigger happy onto our quotient rule, there's a constant up top. A constant up top is a good thing. That means that I can rewrite f of x as 3 and then 2x squared minus 7x plus 5 to the negative 1 power. And in this particular instance, I can use chain rule to subvert quotient rule. Now again, I'm only doing this because there's a constant up top. If that was 3x at the top, I would be using quotient rule absolutely. So let's go ahead and find out what f prime is. F prime of x is going to be negative 3, and then 2x squared minus 7x plus 5 to the negative 2. And then don't forget chain rule, of course, for x minus 7. So what does that equal? Well, that's going to be negative 3, and then 4x minus 7 over 2x squared minus 7x plus 5 all squared. So let's go ahead and find out what the slope is at 3. So that's going to be negative 3 times 4 times 3 is going to be 12 minus 7 over 2 times 3 squared, so that's going to be 9 minus 7 times 3 plus 5 all squared. Now again, you could probably just leave it like this, and then the AP exam would grade it for you. But, you know, we're switching to an online test, so they may ask you to simplify everything. So let's just go ahead and simplify what we can. This dude will become a 5. I'm getting negative 15 up top. Looks like we're going to get 18 minus 21 plus 5 squared. So negative 15 over, looks like negative 3 plus 5, so 2 squared, which is 4. So I'm getting negative 15 over 4. And that'll wrap up the first question. Let's go ahead and move on to the next one. Alright, let's take a look at part B. It says find the x-coordinate of each critical point of f on the interval 1 to 2.5. Classify each critical point as the location of a relative min, relative max, or neither, and justify your answers. Okay. Well, in order to figure out relative mins and maxes using critical numbers, I'm going to use this guy. This is my first derivative here. So I'm actually going to transfer him over to here, and I'm going to scroll to the right a little bit, so just kind of bear with me here. And while I transfer him over, I'm going to do something to the denominator, just because it'll help me see it a little bit better, I think. So I'm going to get negative 3, or f prime of x is equal to negative 3, and then 4x minus 7 over 2x minus 5, and then x minus 1. And I think that's going to get me this factor here, negative 2, negative 7, or negative 5. I think I'm good for negative 7. So from there, that's all squared. So in order to find relative mins or maxes, I'm going to go and punch this guy into a sign chart, where my critical numbers are going to be 1 and 5 halves, or 2.5, coming from the asymptotic areas of the derivative. So 1 and then 2.5. And then this guy's going to get me 7/4. And so from here, this bottom piece is always positive, so I actually don't need to worry about him. He's just a standard issue parabola, always positive, so I don't need to worry about him. From here, the linear function up top, he is an upside down line, so he'll go plus, plus, minus, minus. And since we're going from plus to minus at 7/4, we can then say f, and I'll move him down, has only one critical number on the interval 1 to 2.5 at x equals 7/4. F has a local max at x equals 7/4 because f prime goes plus to minus. And I think that will wrap up part B. Let me go ahead and clean things up a little bit, and we'll get ready for part C. All right, let's go ahead and take a look at C. It says using the identity 3 over the quadratic is equal to 2 over this thing minus 1 over this thing. Evaluate from 5 to infinity the integral of f of x, or show that the integral diverges. So, a couple things. One, thank goodness they did the partial fraction decomposition for us, so we don't have to do that. And all we have to do is just evaluate this integral with one of the limits of integration going to infinity. This screams improper integrals. So, an improper integral will be the limit as k goes to infinity of the integral from 5 to k of the 2 over 2x minus 5 minus 1 over the x minus 1 dx. Pretty simple integral. This guy on the right side here is going to go to ln of x minus 1. This guy here is a little more complicated. He's going to go to ln of 2x minus 5, but then he has to get multiplied by another 1/2 due to rule chain, because when I derive this ln of 2x minus 5, a 2 will chain out, so the 1/2 has to preemptively cancel the 2. Speaking of cancellation, the 2's here will cancel each other out, giving me from limit as k goes to infinity, and I will evaluate him on 5 to k. These two logarithms can actually combine out to become 2x minus 5 over x minus 1 on the interval from 5 to k, and don't forget the limit as k goes to infinity. Now technically I don't need the absolute values there because our interval is completely positive, but I'll just keep them there just because. And let's go ahead and evaluate this thing. Let's go ahead and do limit as k goes to infinity of ln of 2k minus 5 over k minus 1 minus ln of 10 minus 5 over 5 minus 1. This is going to become ln of 5 over 4. And then if I take the limit as k goes to infinity, this piece going to infinity, he'll go to infinity and he'll go to infinity twice as fast. So I'm guessing this is going to become ln of 2. And from here you can go ahead and just leave it like that, or if you want you can combine your logarithms once again to make this 2 over 5/4, making it ln of 8/5. So from here, let's go ahead and get ready to move on to part D. It says, now, determine whether the series from 5 to infinity of that exact same thing converges or diverges. State the conditions of the test for determining convergence or divergence. Now, this particular year on the AP exam, this question wouldn't show up just because you have to use one of the tests that is not going to be covered. But we know how to do it. I mean, it's not that bad. The easiest thing to do is to notice that because C converged, the series has to converge. So what you could say, that would be the fastest thing, is you'd first establish, you would say let, and then I'm going to give myself space here because I'm going to actually fill that in. Let f of x equal that thing. F of x is positive, continuous, and decreasing for all x greater than or equal to 5. And then from here, you can initiate your integral test. Now from here, you can go ahead and just copy and paste your integral test from part C into part D. So assuming you did all that, you could just say, therefore, by the integral test, the sum must converge because f of x also converges. And I'll go and fill in all those spaces right now. So from here, I will say let f of x equal 3 over 2x squared minus 7x plus 5, and that should be greater than or equal to. And then therefore by the integral test, this piece filled in should be the summation from n equals 5 to infinity of 3 over 2n squared minus 7n plus 5 must converge because f of x also converges. So I think that just about wraps it up for this video. Let me know if you have any questions or comments. Put them in the comment section as always, and I will see you next time.